This
expert.
conference will now be recorded.
Okay. Uh, Today we'll discuss how to become Hadoop expert in Hadoop admin in next 50 hours. Okay, let's move on. This will be our agenda for today. Why Hadoop is a huge man? One, what is big data and its sources? What are the characteristics of big data and what are its categories? And what are the disadvantages of traditional RDBMS system and advantages of Hadoop? What is Hadoop and its history? And its architecture, its daemons, what are the different core components of Hadoop, and we'll try to see how to set up a simple Apache Hadoop single node setup on our laptop. Okay, yeah, let's start, folks. Uh, these are some of the numbers. Why is it a good idea to learn Hadoop? These are some of the numbers that are coming from giants such as Forbes. They are saying that by 2022, you'll see that Hadoop market raised by $99.31 billion. And this is coming from payscale.com. It's saying that the Hadoop professional salary will vary from $93K to $127K. And this is again coming from IDC. The numbers are almost similar. By 2020, we can see the Hadoop market going beyond $210 billion. Interesting, right? So this is a very good reason why people are shifting their careers towards Hadoop. And this is an interesting number which I took it from Hadoop professional in United States. It's saying the annual salary of Hadoop employee in United States is somewhere close to $112,000, which is 95% greater than the salaries of all other job postings. And if you compare the salary of Hadoop with all other technologies, Hadoop is leading the trend here as well. Okay, and if you see one more reason why people are shifting towards Hadoop is there is acute shortage of skilled professionals in Hadoop, and it will be the case for next 2 to 3 years at least. And these are the numbers which are filled and unfilled in Hadoop, and see a lot of these jobs are yet to be filled. So it will be the case for next 2 to 3 years. And these are some of the roles and responsibilities of Hadoop admin as a part of daily basis. So we'll see one by one, and then in our actual sessions, we'll try to implement each of these. So installing Cloudera Manager, and then installing CDH using Cloudera Manager, adding a new node to the existing cluster, adding a new service to the Cloudera Manager, and creating HDFS users home directory, configuring name node high availability, and configuring resource manager high availability. How to set up alerts in case of excessive disk fills, how to commission or decommission a node to the existing Hadoop clusters. Let's move on. Who can learn Hadoop admin? See, anybody who is good at basics of Linux can become Hadoop admin, but you don't need to worry because even we'll be covering basics of Linux as part of our first module itself. So literally, there are no prerequisites. Only prerequisite is commitment and dedication from you guys. So if you guys can dedicate 1 hour per day for practice of Hadoop admin for next 2 to 3 months, you can see yourself working in your dream job in next 2 to 3 months. Okay. Coming to the sources of big data. Sources in a sense, where is this big data coming from? Right now we are in 2018, and nowadays everybody is using internet in somehow or the other, either the mobile or the laptop. These are the numbers that are happening in 2018 per minute. If we take our very famous social networking website, Facebook, it's saying that 973,000 logins are happening. And if you take Google, 3.7 million queries are being searched. Similarly, our one more famous social networking app, uh, WhatsApp, is saying that 38 million messages are being transferred per minute in 2018. And similar is the case with Instagram, and many apps are being downloaded from Google Store or iPhone App Store. And 4.3 million videos are being watched in YouTube. These are some of the staggering numbers. So these all contribute towards the sources of big data. Let's see what is the actual definition of big data. See, as the name suggests, big data is kind of huge data, which cannot be stored and processed by the traditional systems such as RDBMSs. Interestingly, 90% of the data that's available in today's world has been generated in the past few years. And this is the memory chart. What are the different kinds of memories available? 1 byte is nothing but 8 bits, and 1 KB is 1024 bytes, 1 MB is 1024 KB, and 1 GB is 1024 MB, 1 TB is 1024 GB. So when can we say that we have a problem of big data? So if you are seeing any data that is being generated is beyond this TB, if it is something in PB petabyte or EB exabyte or zettabyte or yottabyte, you can say that we have a big data problem. Okay, and let's move on and see what are the different categories of big data. Generally, there are three types or three categories of big data. One is structured data, other one is semi-structured data, and unstructured data. So if you take the first one is structured data, if you take an example of RDBMS table, what is the format of RDBMS table? It will have rows and then it will have columns. So it have a proper structure in the form of rows and columns. So RDBMS table can be considered as an example of structured data. And if we take an unstructured data, nowadays almost all the homes and offices are being installed with the CC cams. So CC cams might be generating huge amount of videos. So the videos can be an example of unstructured data. Even the audio can be example of unstructured data. A lot of mails are being transferred, so even the mails can be considered as example of unstructured data. And if we take semi-structured data, the examples can be XML and JSON. And okay, so guys, if you have any questions, you can stop in the middle and then you can go ahead, or even you can put your question in your chat. So that's not an issue. Okay. In short, we have three types of data: structured data, semi-structured data, and unstructured data. Okay. And then we'll go ahead and see what are the different characteristics or three V's of big data. So, what are the three characteristics or ways of big data? First one is variety. We have just seen that there are different forms of data: structured data, unstructured data, and semi-structured data. So, all these data will fall under any of the one category: text data, sensor data, legacy docs, images, audios, and videos. So, variety is nothing but different forms of data that's available in the market as of now. And coming to our next V, velocity. Velocity is nothing but the speed at which the data is being generated. And these days, everybody have a Facebook account, and then we will be posting something every second or minute on an hourly basis or daily basis or weekly basis. So velocity is nothing but the speed at which the data is being generated. And coming to our next V, which is the final V called volume. Volume is nothing but the quantity or the size of the data that is being generated. So the size can be in MBs or GBs or TBs or PBs. So in short, big data is a combination or intersection of all these three ways put together: variety, velocity, and volume. Okay, any questions, guys, till now? If you have any questions, you can unmute yourself and then talk, or you can put your questions in the chat. Okay, so coming to our next thing, we have seen people using big data and Hadoop interchangeably or using as synonyms these days. But remember, guys, big data and Hadoop are both are different terms. So big data is the problem that with the characteristics that we have seen, and for every problem in the universe, there should be some solution. So the solution is Hadoop. So in short, big data is the problem, and Hadoop is the framework to solve big data problem. Okay. Now let's see what are the disadvantages of traditional systems and what are the advantages of Hadoop. First parameter is storage limit. If you take any traditional RDBMS system, there is some sort of storage limit. You cannot store data beyond such some limit. But that's not the case with Hadoop. You can store huge amount of data. Coming to the next parameter, varieties. RDBMS can store only structured kind of data and process structured kind of data. But whereas Hadoop can store structured, unstructured, and semi-structured data. Coming to the cost of the software, if you want to work with any of the RDBMS softwares, you'll have to have a licensed software by paying huge amount of money. Not only that, you'll have to renew the license again every few years with huge amount of money. And processing type, imagine coming to the cost of software in Hadoop, it's absolutely free of cost. Coming to the processing type in RDBMS. So let's take an example. I have a database called world's population, and I want to retrieve uh, the population of the people who are living in US. So that's going to take a lot of time because traditional RDBMS systems will make use of serial processing, and that will take a lot of time. And coming to Hadoop, it's make use of it's make use of distributed parallel processing, where we'll be distributing the data onto the different data nodes, and then we'll be processing it. So we'll see the details of that storing and processing in detail in our next slides. Just remember that Hadoop is based on distributed or parallel processing. Coming to the cost of the hardware, so RDBMS systems need to have a high-end servers. Then only we can make things happen in RDBMSs. Whereas Hadoop even work with kind of commodity hardware as well. Source code. Coming to source code, RDBMS source code is not open source. What does that mean? So even if you don't like a feature, if you're facing some slowness or stability issues in your current version of RDBMS software, you have no other option but to wait until the next release or next version comes. But that's not the case with Hadoop. It's an absolutely open source, so you can download your code, you can play with it, you can modify it, you can customize it as per your need, and then you can move on. Okay, these are some of the advantages of Hadoop. What is the difference between big data and Hadoop? See, big data is the problem, and whereas Hadoop is the framework to solve the big data problem. I hope that answers your question. Let's move on. What is the history of Hadoop? See, Doug Cutting is the founder of Hadoop. When Doug Cutting was working in Google, which is a famous search engine, so many millions of queries are being searched. So Google was facing a problem as in how to store the data. So that is when Doug Cutting published a paper in 2003 called GFS. GFS stands for Google File System. So this is the file system where they were storing the huge amount of data, and that white paper even led to another white paper in 2004 called MapReduce. So MapReduce is the processing layer that processes the data that is stored on GFS, Google File System. And this Doug Cutting named it as Hadoop because you might be seeing a small elephant, something closer to Hadoop, because it came from his son's toy elephant name. So that's how he named this technology as Hadoop by looking at his son's toy elephant name. And what is Hadoop? As I already said, it's an open source project that came from Apache Software Foundation, and it is mainly used to distribute our data and then process the data that is stored on the data nodes. It took inspiration from Google file system, which is the storage layer, and the MapReduce programming model. Initially, this Hadoop was originally written as a sub-project for Nudge search engine project, but because of its popularity, when Doug Cutting moved from Google organization to Yahoo organization, it actually became a main project, and it actually became an open source framework. This is actually absolutely written in Java, but as a Hadoop admin, you don't need to worry about learning Java. You don't need Java knowledge to work as Hadoop admin. You just need only Linux basics. Even then, you don't need to worry because I'll be taking Linux basics as a first module. So literally, there is no prerequisite to become Hadoop admin. Only prerequisite is dedication and commitment. If you can commit yourself for to practice for next 2 to 3 months every day 1 hour, that is good enough. You can become Hadoop admin in next 2 to 3 months. You can see yourself as Hadoop admin. And see, this Hadoop is a framework that efficiently processes the large volumes of data and a cluster of commodity hardware. What do you mean by the term cluster? Cluster is nothing but group of computers or servers connected together, which who hardware is commodity hardware. So this Hadoop can be set up on a single machine, or but the real power comes with cluster of machines. So when group of computers are connected together, that's when this power comes. So it can be scaled from single machine to thousand machines on the fly. What do you mean by on the fly? See, even if you want to add a special node, new node, even if you want to delete a node, you don't need to worry because absolutely there will be no downtime at all. You can absolutely add or delete the nodes on the fly. Let's move on. This is a kind of interesting story. Uh, there lived a king in a kingdom, and on the minister. One fine day, king wanted to find out how many people are living in his kingdom. So that's when he called minister to find out how many people are living in his kingdom. Minister just obeyed his order, said that, okay, king, I will go and find out how many people are living in our country. So then this guy minister went alone initially, and then he almost took 10 days to figure out the number of people living in his kingdom and set the count to king. But the king is not happy, though he got the number, but he is not happy because the minister took almost 10 days to figure out how many people are living in his kingdom. That's when king suggested to take help of the rest of the soldiers as well in order to find out the count of the people in the kingdom. That's when minister took the help of the other soldiers as well, and then within no time this guy minister came back with the count, and the minister is and the king is absolutely happy because minister finished the job within no time. So if you can compare the initial process or the first process called sequential processing, because initially only minister was working alone. That's why he took a lot of time to figure out how many people are living in his kingdom. Coming to the next approach, which is distributed processing or parallel processing, this guy minister took help from all the other soldiers. So that's when the job was made easy. Made easy. So in our Hadoop architecture also, we can compare this king as master and the minister and the other soldiers as slaves. So if somebody asks you what is Hadoop architecture, you should be in a position to say Hadoop architecture is based on master and slave model. You can compare this kind of master is king and the slaves are ministers and then other soldiers. Okay, so Hadoop architecture is based on master slave model, and it's based on distributed processing and distributed storing, because we'll be storing our data onto the different all the different slaves. See, master is nothing but a computer, even slave is also nothing but a computer. So it's a kind of distributed processing and storage model. Okay, let's move on. 1 minute, guys. Yeah. So this master in Hadoop terms is called name node, and whereas the slaves or is called data nodes or the worker nodes, and then there is something called secondary master, which is called secondary name node. So just remember these terms, guys. So we'll be using these terms in our coming slides. Okay, master is name node, secondary master is secondary name node, slaves is nothing but data nodes or the worker nodes. Okay, what is Hadoop and its core components? So we've seen what is Hadoop, and let's discuss about Hadoop core components. So Hadoop is a combination of two core components. First one is HDFS, second one is MapReduce. What does HDFS stands for? HDFS stands for Hadoop Distributed File System. So this is a storage layer of Hadoop. So this is the place where all the data will be stored. And whereas MapReduce is the processing layer of Hadoop, this will process the data that is stored in HDFS layer. So in short, Hadoop is a combination of two things or two core components. One is HDFS, other one is MapReduce. Okay, let's discuss in brief about each of these core component. First one is HDFS. So it's a kind of distributed file system. Why is it distributed? Because we'll be storing our data onto the different data nodes or the slave nodes, and we will see why it is called fault tolerant in the next 2 to 3 slides. Okay, just remember this term. HDFS stores multiple copies of data onto the different data nodes. Just remember this term multiple, guys, because we won't be storing only one copy of data. We will be storing multiple copies of data onto the different data nodes. Imagine a situation where I have a huge file. Okay, and in order to store that file, I'll be splitting or breaking that file into small pieces. Each small piece is called block, and then I'll be storing all those blocks onto the multiple data nodes. Okay, and that to maintaining multiple copies of each block. Okay, two things to remember. One is multiple blocks and multiple copies of each block. Okay, there are different versions of Hadoop. There is Hadoop 1.x version and then Hadoop 2.x version. So we have just seen that we'll be breaking a huge file into small pieces. Each small piece is called block. So the block size is 64 MB by default in Hadoop 1.x. The block size is 128 MB by default in Hadoop 2.x. Okay. Hadoop cluster. Cluster, as I already said, is nothing but a group of computers connected together. Hadoop cluster is a combination of name node and then multiple data nodes put together to form HDFS cluster. Let's go ahead and see how to create blocks in HDFS. See, imagine I'm using Hadoop 2.x version. What is the default block size in Hadoop 2.x? 128 MB, right? So our task is to break this file of 260 MB into small pieces. So how will you make it? How many blocks will it come? So we know that the default block size is 128 MB. So we will make this file into blocks by dividing this into blocks by dividing by 128. So if we divide 260 by 128, it will come something close to 2 point something, right? So we are pretty sure that there will be two full blocks. Right. What do you mean by full block? What is the size of block in Hadoop 2.x? 128 MB. So there will be two 128 MB blocks. If you add these two 128 MB and 128 MB, it will be 256 MB. So if you minus that 260 MB minus 256 MB, so there will be fourth block of size 4 MB. So if you add these three, it should come as 260 MB. So in short, the answer is there will be three blocks created, two blocks of 128 MB and one block of 4 MB. So this is how we break a huge file into small pieces in the form of blocks in HDFS. Okay, and Hadoop fault tolerance. As I already said, imagine that I have a large file and I want to break that large file into small pieces in the form of block 1, block 2, block 3, block 4. So and then I'll be distributing those blocks onto different data nodes. I have B1 here, I have B2 here, and I have B3 here, and I have B4 here. Now our job is to read this large file. But in order to read this large file, we need four things: block 1, block 2, block 3, block 4. As I already said, each of these blocks will be distributed in multiple copies. You see, B2 is here, B2 is here, B3 is here, then B3 is here, and then B4 is here, then B4 is here. But one day, this machine on which this B1 is there is completely down. So, but in order to read our large file, we need to have all the four blocks. We have B2, we have B3, we have B4. But this machine on which this B1 is available is completely down. But you don't need to worry, as we have another copy of B1 stored on the other data node. So what do you mean by fault tolerance? So without any downtime or without any impact, you should be in a position to read this large file even now, because it will work as if nothing has happened. That is what is called as Hadoop fault tolerance. Okay. Let's move on to the next core component, which is nothing but MapReduce. MapReduce is the processing layer of Hadoop, and it is used to process the large data sets or huge amount of data that is stored on the cluster of data nodes. Okay. And imagine a situation, I want to read that large file again. So in order to read or process that large file again, I need four blocks: B1, B2, B3, B4. So that's why I wrote a program called MapReduce program, and then I will submit that MapReduce program to master. But the master is completely aware of, in order to read that large file, it needs four blocks, and all the four blocks are stored on different data nodes. So what this master will do is, it will just copy this MapReduce program. The same program will be copied onto the different data nodes on which that is available. Okay, that is how we process the data using MapReduce. So to summarize how Hadoop works, it involves four steps. Step 1, 2, 3, 4. Step 1 and 2 are based on HDFS, because we will break our input data into small blocks of 64 MB or 128 MB. Then we'll move them into the different data nodes. Once all the blocks are stored on the different data nodes, then we will submit our MapReduce program to the master. Then the master will copy the same program onto the different data nodes on which the required blocks are there. Finally, the output will be returned back to the HDFS. Okay. So let's see what are the different Hadoop daemons available. So before going ahead, let's see this term called daemon. So you might be seeing kind of task manager in the Windows operating system, right? So daemon is a kind of the task manager is a kind of daemon. So the task manager will start running as soon as you start your laptop, and then it will keep on running until you shut down your laptop, right? So the task manager can be considered as daemon. It's a kind of process that will be running perpetually or continuously until your system is up and running. Similarly, we have seen there are two layers in Hadoop. One is HDFS and the other one is MapReduce. So we have seen that HDFS is a storage layer, right? And MapReduce is the processing layer. So in HDFS, which is a storage layer, we have total three daemons running out out of which these two name node and the data node can be name node and the secondary name node can be considered as master daemons in HDFS, and data node is the slave daemon in HDFS. So in short, this HDFS has total three daemons running together all the time: name node, secondary name node, and data node, out of which the masters in storage layer are name node, secondary name node, and the slaves are data node. Okay, and if you take MapReduce, which is the processing layer, it will have again master, which is nothing but the job tracker. So this is the one that takes our MapReduce program, and then it will give to the task tracker. Okay, in short, you will have to remember there are two daemons running in MapReduce. One is job tracker, and then the other one is task tracker. Okay, let's move on and see how these will be available. We have seen there are two layers in Hadoop. One is storage layer, and the other one is MapReduce layer, which is the processing layer. In storage layer, we have seen that the master is name node and the slaves are data nodes. Similarly, in the processing layer, we have seen that job tracker is the master, and then the task tracker is the slave daemon. So this is how it will be available in the architecture. So we have this HDFS, which is a storage layer, and then we have this MapReduce layer, and these are the daemons. So on data node, on the same data node itself, data node, which is the slave of HDFS layer, and then task tracker, which is the slave of MapReduce layer, will be running together. And on the name node, all this name node, which is the master of HDFS layer, and then this job tracker, which is the master of MapReduce layer, will be running together. Okay. And what are the popular flavors or distributions of Hadoop? So initially, Apache Software Foundation is the one that submitted the Apache Hadoop code, and then later on, these vendors, Cloudera, Hortonworks, and Mapper, they just customized it and then made it as proprietary, and then they're releasing their Hadoop flavors or distributions into the market. And today we will see how to make a simple setup on your local laptop. So for that, we need two softwares. One is VirtualBox, other one is Ubuntu VM. So let me take an example here. Imagine that I have an MP3 audio song. So in order to listen this MP3 audio song, we need to have some sort of player, right? So such as Windows Media Player or VLC Media Player. So this can be compared to that. So we need to have Ubuntu VM available, and then in order to use this Ubuntu VM, we need to have this VirtualBox software. And now we will go ahead and see how to download each of these and how to install each of these. First one is downloading Oracle VirtualBox. Just go to Google and type download VirtualBox. Click on this first link, and then click on this Windows source or the host or the operating system, whichever you are using. So once you click on this, that will download a software for you. So once that is downloaded, you can just double click on it to install the VirtualBox. Click on next. So installation of VirtualBox is pretty much similar to all any other default software installation. You can click on S, and then you can click on install this, and then if you can click finish, this will open up VirtualBox for you. So we have seen how to download and install VirtualBox. Now let's see how to download Ubuntu VM. Just go to Google and type download Ubuntu server VirtualBox. Then click on this second link. Just open this and then click on this desktop image. Once you click on this, it will be downloaded. You can just click on File, open this VirtualBox, and then click on New. give some name. I'm just trying to give the name as H name node, Hadoop name node, and make it as Linux and Ubuntu. Click on next, and then it will be something like this. So these network settings are needed to be made in Ubuntu VM because our Ubuntu VM should have internet connectivity in order to install the softwares or browse to the internet for any documentation or something. So we will just click on right click on this, click on settings. You can just click on the network, select adapter 2, and then enable this network adapter. Select host only adapter here, then click on OK. And then once that is imported, you can just right click on it, click on start, do normal start. Then it will take some time and then it will open up. So now let's see how to install simple Apache Hadoop on our single node cluster. What do you mean by single node? So we have just seen that there are total 5 daemons running together. 3 daemons are from storage layer and 2 daemons are from processing layer. So those storage layer daemons are name node, secondary name node, and data node, and processing layer daemons are job tracker and task tracker. And now we will see how to make a simple setup, single node cluster setup on our laptops. So remember guys, as I already said, you don't need to worry because we'll be using some of the Linux commands. Even if you don't know Linux, you don't need to worry because our first module will be Linux basics. So that is when I'll be covering all the basics that are needed to work as Hadoop admin. Okay, let's move on and see how to install step by step. Installing SSH server. How do you install SSH server? By using this command apt-get install. See, we are already using our phones and then we have Google Store or iPhone App Store. How do you install WhatsApp? You just go to Play Store and then type WhatsApp and then click install. It's something similar to that. You'll just use apt-get install and just you are using the software which you want to install, open SSH server. Then once that is done, you'll just generate the keys to make passwordless login by using SSH keygen. And then you will copy those keys by using this command. Okay. And then you will, because as I already said, Hadoop is completely written in Java. You need to have Java or JDK installed on your system. So this is how you install Java on the machine. And then you will untar this Hadoop file and then copy it into this path. Then in our next step, we'll update our bash rc file with the Hadoop environment variables, and then we will reset and commit the changes in bash as shown in step 7. Then in the step 8, we'll be going to this file called hadoop-env.sh, and then we'll be making this change as by updating java underscore home environment variable. After updating that, we will go to the core-site.xml in this path, and then in that path we'll be updating with the name node details here, and then in map-site.xml we'll be updating with the job tracker, which is the master in MapReduce or the processing layer. Once that is done, we'll be making a directory. mkdir stands for making a directory like this, and then we'll be changing the ownership of the directory. That's what chown is meant for, changing the ownership of the directory. So once that is done, we'll be having a script called start-all.sh. So you just go to that script and then run it as shown in the slide. So once you run it, you should be in a position to see all the daemons running together. So we have seen that there are 5 daemons totally: name node, data node, secondary name node, which are from storage layer, and then job tracker and task tracker. So that is what a single node cluster setup is called. So we'll be seeing all the 5 daemons or all the 5 services running together on the same machine. Okay. And what is the summary of this session? We have already seen that big data is nothing but huge amount of data which cannot be stored or processed using traditional systems. And we have seen that big data is a combination of 3 things put together: volume, velocity, and variety. We have seen that big data is a problem, and whereas Hadoop is a solution to solve that big data problem. And we have seen that Hadoop is a combination of 2 core components: HDFS and MapReduce, which is this is the storage layer and this is the processing layer. And we have seen that there are 2 versions of Hadoop they're available as of now: Hadoop 1.x and Hadoop 2.x. We have seen that we'll be breaking our file into small pieces. Each small piece is called block. So block size is 64 MB by default, in Hadoop 1.x, block size 128 MB by default in Hadoop 2.x. Okay, and see guys, after each and every class, I'll be giving some sort of interview questions on daily basis. So if you go to this website live courses and then if you click on Hadoop, uh, so I'll be giving 10 questions after every class. So if you take an example of if the classes goes for 40 to 50 days, it will be almost 400 to 500 interview questions. And of, after each and every class, I'll be giving some sort of assignments as well, something like this, along with some hints. So at the end of this course, you will be working on 400 to 500 different interview questions on 40 to 50 different assignments with the answers provided in a separate document. So I would highly suggest to solve it on your own and then refer to the answers at the end of completing your interview questions or assignments. Now let's see some of these sample questions which are developed based on the topics that we have covered as of now. Let's see if we can answer these questions. What is the default block size in Hadoop 2.x? 128 MB, right? And then we'll move on to the next question. What is the master node in Hadoop? We have seen it is name node. Hadoop follows distributed parallel processing mechanism to process big data. True, right? Which of the following can be considered as characteristics of big data? All. Hadoop is the solution to solve the big data problem. Absolutely true. And which of the below can be considered as worker nodes in Hadoop? Data nodes, right? And then select the popular Hadoop distributions from below. Cloudera, Hortonworks, Mapper, all the above. Then is Hadoop fault tolerant? Yes, absolutely. There will be no downtime at all. So which of the below is a traditional in RDBMS led to the evolution of Hadoop? Just recheck this question again, guys. So I'm talking about what are the disadvantages of traditional RDBMSs that led to the evolution of Hadoop. Storage limit constant, right? So into how many blocks a file of 260 MB will be divided into in Hadoop 2.x? First thing you have to see is which version of Hadoop are we using? Hadoop 2.x. What is the default block size in Hadoop 2.x? 128 MB. So you'll have to divide this file of 260 MB into blocks. So 260 MB by 128 MB, it will come something 2 point something. So there will be two full blocks of 128 MB, and then the leftover part, which is 4 MB, will be created as another block. So the answer will be three blocks. Total three blocks will be created. Okay, and then if you click on finish, this is how it goes, guys. So after each and every class, I'll be giving at least 10 interview questions, which are based on the class that completed, and as well as the assignment on daily basis along with the hints or the answers. Okay, at the end of this course you'll be working on 400 to 500 different assignments on interview questions as well. So I think there is no reason why you can go and do your job search in Hadoop. So this is what you are going to get at the end of this course. Become employable in Hadoop or big data industry, because we'll be seeing almost 400 to 500 different interview questions on daily basis along with answers on 40 to 50 different assignments. So if you can work on them, I think you are good enough to go ahead and work in Hadoop industry and gain practical skills from these sessions. We'll be working on some smaller projects, and then I'll be giving a live project to put in your CV, so you can update your CV as per your need in your CV at the end of this course. And this will be our Hadoop admin course content. First thing we'll be discussing Linux basics that are needed to work as Hadoop admin. Then the second module will be big data. Third module will be based on Hadoop. Then the fourth component is Hadoop HDFS, which is our Hadoop core component. And these are the type of hands-on practices we'll be doing as part of this module. These many. And then our next module will be MapReduce along with the some sort of labs with it. Then our sixth module will be Hadoop 2.x along with the labs. Okay. Then we'll move on to the next module, which is cluster planning. And then eighth module based on how to install and configure Cloudera or Hortonworks. And our ninth module will be how to monitor and administer the Hadoop clusters. Our 10th module will be based on Hadoop ecosystem tools. 11th module is based on how to do other admin concepts. and our last module will be real-time concepts. Okay, and what is the specialty of our Hadoop training? See, our Hadoop training is based on morely towards the hands-on oriented because that's what is needed by the industry. And we'll be giving all the mock interviews. We'll be giving on a daily basis. We'll be getting recording of this session along with the PPT that is covered, along with 10 different interview questions, along with the answers of it, along with one assignment, along with the answers of it. So, and at the end of the course, we'll be giving some real-time interview questions, sample resumes to update your CV, and then we will make you ready to go to the interview and meet interview's expectations. And even if you have any questions while answering the interviews, you can take those questions to me and I will try to answer those questions for you. Okay. Any questions, guys? So, any questions till now on any part, whatever was covered? You can unmute yourself and talk, or if you want to put it your question on the chat, you can put your question in chat. Any other questions, folks? So, folks in the meeting, so if you have any questions, you can unmute yourself and then talk. Mohammed, if you have any question, you can ask. Mohammed, do you have any questions? You can unmute yourself and talk, or if you want to put your question in the chat, you can put there as well. Okay, okay. No, I'm good. Okay. Oh, okay, Mohammed. Okay. Okay. Okay, guys. Okay, guys. If you have any questions or queries, you can still reach out to me. Okay, you can take help from Money Vanan, and then you can reach out to me. Okay, guys. Okay, yeah, sure. Mohammed, can you send us your email ID so that I will send this meeting, but send this recording to you. So I'll be sending. Okay, cool. We will send this recording along with the PPT, along with the interview questions and the assignments as well to this mail ID. Okay.
So that's perfect. Thank you very much. Appreciate it.
Okay. Bye bye.
Thank you very much, guys.
Yeah. Bye bye.
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 Why?